if there's one question that parents ask me, just more than just about any other question, it is, why are they teaching math so much differently now than they did when we were growing up? Why don't they just teach the standard algorithms? Why aren't they helping kids just get to the answers and get them quickly? And why are they spending so much time on these things that seem so inefficient? And I have an answer to that question, and I'll start by saying, we have decades of research that shows that teaching people just to memorize algorithms and execute procedures hasn't worked. It's worked for a small group of people, but for most people, they don't like math, they don't enjoy math, they don't think they're good at math, they have a really hard time with it because no one taught them to understand the concepts and why we're doing what we're doing. We didn't teach kids how to think, we just taught them how to do and execute in this misguided idea that we just need them to get to the answer as quickly as possible. But if we step back and think about it for a second, in this day and age, being able to execute an algorithm in arithmetic to get an answer is a fairly useless skill. Your child and yourself, you have a computer, a calculator, a phone, you have instant access to computing devices at your fingertips. And those devices are going to be more accurate and faster than you are. So what we need to be doing, and this is part of the shift that is being made in education now, is starting to teach kids to think and understand and sometimes use different strategies to solve problems, because the standard algorithms, while they always do work, are not always the most efficient. And I can give you several examples of that. So let me start with a multiplication example, two-digit multiplication. And as students, we may have learned it, or you've probably learned it, to do the standard algorithm. Line your numbers up vertically, and then start with a ones column and go. 4 times 5 is 20. We're not allowed to write the whole 20 here. We just write the 0 and bring the 2 up there. So that's the first place where we're doing something that is kind of weird. Then we do 4 times 4, which is 16. We have to remember to add in the 2, which is 18, and we place that there. Again, we haven't really told anyone exactly why we're doing that, but that's how you execute the procedure. Then you put in your, what I used to call the placeholder 0, so you put a 0 here. And you move over to this number, and you do 2 times 5 is 10. You only write the 0, and then we don't need this anymore. We carry a 1. And then 2 times 4 is 8. We have to add in that 1, which is 9. And then we add these all together, 0 and 0, 0. There's an 8, and here's 10. And it's 1,080. Hopefully that's right. Now, these days, before we teach kids the standard algorithm, we might teach them what's called partial products, where we're going to help them see what's going on with place value in these problems. So again, we'll start with 4 times 5, which is 20. And we'll just go ahead and write that whole thing right here, 20. That's the first part of the problem. The next is we're going to do 4 times this 4. But we're teaching students that this is not a 4. It is the digit 4, but when it lives in this column, it actually represents 40. 4 times 40 is 160. And you'll notice this is the 180 that was there, so there's nothing really different going on here, just in how I write it down. Then I have not 2, but 20 times 5, which is 100. And I have 20 times 40, which is 800. And you'll notice again, these two here are 900, that's just what we had there. We'll add them all up, and we will get 1,080 again. Now, you might say, well, this isn't very efficient. Look how many steps that was. Look how many things I had to write down. And you're right, but we now have a conceptual understanding of place value. We're not having to write numbers up here and scribble them out, which is a bit confusing. And we're still getting the same result. So we'll teach this to students first so they understand what's going on. Later we can teach them the shortcut so they can save a tiny bit of paper to get to this answer. But there you go. And then we might even give them a visual picture of what's going on. When you multiply two numbers, you can think of that as the area of a rectangle. And this rectangle would be 24 units on this side and 45 units on that side. And if I break it up like this, and I imagine this to be 40 and 5, and this side to be 20 and 4, then I can compute the area of these 4 little internal rectangles. This one here is 20 by 40, which is 800. This one here is 40 by 4, which is 160. The little one is 5 by 4, which is 20. And this other one, vertical one here, is 5 by 20, which is 100. And you'll notice those are all the same numbers that we had over here. Okay, so this is the same thing, but now I'm giving you a visual picture of what's going on. And it turns out that this picture becomes in really handy when we get to algebra, because we could replace these with variables and still be able to figure things out. But that's probably an aside for another time. But now I have different ways of conceptualizing what's going on before I get to the standard algorithm. Okay? This helps kids understand. It helps kids apply concepts rather than just memorize. And it also helps them identify times when they don't need the standard algorithm. So an example of that would be, say we have 73 times 10. I can't tell you how many times I've seen students line that up vertically just like this and execute the algorithm and put in a bunch of zeros and go through all the steps to get a result that they should have been able to get just using their mind. If you understand place value and what 10 means in our number system, then 73 times 10 is just 730. You're just moving the decimal place. But again, if you don't understand the concept, all you have to fall back on is a procedure which gets you a result that sometimes you don't even know if the result is correct or not. You just have to assume it is, hoping you've done everything right. So this is why we're teaching math so much differently now. And there is research that shows that when you give people a conceptual understanding of what's going on, it really helps them get answers that we want them to get and explain their thinking, and also look for better ways to do things, because the standard algorithms are not always the best way to do things. So I hope that helps you as a parent see why math is so much different now. The other thing that is a corollary to that first question is, I don't know how to help my students with the math because it's so different. And these homework assignments look so confusing because I've never seen anything like this before. And I think that question kind of proves the point of, if you learn math in a way where it was always this way, always follow these steps, this is how it works, then you never learn to have flexible thinking, how to take numbers apart and put them back together, how to find shortcuts, how to be creative in mathematics. And that's where some of the beauty, most of it actually, lies in mathematical thinking. Isn't in executing algorithms. That's kind of boring. But learning how to think and solve problems is a lot of fun. And so teaching math this way also can bring back a lot of fun to mathematics. Now I know when you're sitting with your child doing homework that you've never seen before and it looks really different, it can be a little complicated, but I want you to have an open mind. Read the directions, see if you can understand it. I'm not going to say that every homework assignment that ever comes home from school is perfect and well designed. There may be some weird ones out there, but by and large, the goal, if you keep in mind, is to help them understand. I think you'll have a better sense of what's going on and maybe a better mindset for how to help your child with mathematics at home.